The Duke Cardiopulmonary Rehabilitation at Crossdale treats patients with various forms of lung disease. Part of the treatment includes a combination of oxygen therapy and exercise. Patients frequently walk around using a walker to carry around oxygen tanks as they exercise. However, some patients require up to 3 oxygen tanks at once to avoid interrupting their exercise sessions. Current walker attachments usually hold only one tank and prove unstable, as they tip over with relative ease.
Last semester, our design met the basic criteria of what our problem required. Our design was made up of 3 main components: the base, dividers, and attachment. The foundation of our design was a semi-elliptical base of 14 inches in diameter with a caster underneath and a small safety mechanism composed of wire mesh and straps. The dividers were made to separate the 3 oxygen tanks that would be on our design. They were formed in a V shape and back, with a pair of straps per tank. The attachment was made to allow the design to be put onto a walker. It's made of 6 rods of various lengths that were welded together. There were 2 conduit hangers that would go on the ends of the horizontal bar on the attachment that would attach to the legs of the walker. Our old design had some pros in that it was relatively stable, carried the oxygen tanks, and did not alter the walker itself. However, it also had many flaws that limited its functionality. Because it was made of steel, it was very heavy, weighing in at 12.15 pounds. It also had characteristics that decreased its manufacturability, such that it was welded, had sharp edges, and had uniquely made parts. Most importantly, it was not universal. Unlike our new design, the attachment of our old design was not adjustable and could not conform to the various heights and widths of the walkers.
This semester, the team focused on improving the manufacturability of the design, making the attachment universal, decreasing the weight of the device, and adding some user-friendly features. In the end, the group developed a design that can be easily manufactured, is able to attach to multiple walkers, is 25% lighter than the previous solution, and includes various user-friendly features.
For this semester's rendition of our attachment, we decided to redesign and reanalyze our choices of materials and sizes. For the base, we decided on a 3003 aluminum plate. The reasoning for the aluminum plate was to make it easier to mill out the shape which we wanted, and the dimensions we chose were 15.5 inches long by 7 3/4 wide. The reason for the extension to 7 3/4 was to fit the 80/20 attachment that was added to the backside of the base. Our dividers changed shape and turned into a polypropylene plastic material. Our choice in polypropylene plastic was that it was very cost efficient, coming in at about 70 cents per pound. It was very easy to manufacture the shapes we needed using the milling machine, and it was very versatile in our handling of it. In regards to the attachment, we chose the 80/20 bars due to its versatile connectivity and being able to slide in all the components with the appropriate nuts. And the 80/20s were bolted down onto the aluminum base by drilling holes and attaching them on both sides of the 80/20 using 90-degree steel brackets. For the clasps that held onto the horizontal bars on the walker, they were made of 3003 aluminum sheet metal, and on the inner side of it were some high density foam that was chosen to grip the sides of the horizontal bar well. Some of the key features include the straps at the top as well, which were made in the dividers by dremeling out a little gap to slide them in and make it so that they produce a tight fit around the backrest of the walker and are able to hold on from a higher up position along the walker.
Another key feature includes 2 straps on the back of the top dividers. These straps wrap around the walker's backrest and help stabilize the walker during sudden stops or when traveling along uneven surfaces. The team also included two tubes with discs on the end to one of the supporting rods. This user-friendly feature allows users to secure the oxygen supply tubing by wrapping it around these two cylinders.
Our design had many strengths with improvements from last semester. For one, it was lighter than the old design, weighing 9.7 pounds. It was also very stable because it was attached on both the top and the bottom of the walker. We were able to make the design manufacturable. It had no sharp edges, simple and symmetrical parts, and it was easy to assemble. It was also easy to use. It was easy to attach the device onto a walker and replace the oxygen tanks on the device. Finally, our design was universal, unlike last semester. The attachment was adjustable and attaches to various heights within a range of 6 inches. However, our design also has many limitations. The majority of our flaws have to do with the materials we used. We need stronger aluminum for the clasps so that they do not break. We need a steel rail end. And we need lighter rods on the side, which are currently made of steel. Another limitation is the cost. The cost of our device is $150, which is $50 above what we wanted. Lastly, the straps could also be troublesome for users. The buckle could be hard for them to use, and there is a complicated design on the back of the walker. Because many of the flaws stem from material selection, they could easily be fixed. The overall design proved to be very functional and effective, and we were able to meet all of the goals of our semester. With minor adjustments, this device would be ready to manufacture and send to the Duke Pulmonary Clinic.